Good morning, children. Welcome to the Maths B Coordinate Geometry class. And it's a webinar classes conducted by Christ Society. Dear children, in the previous class we have discussed what is polar of a point P with respect to the circle S is equal to 0. And we have seen under what condition the given points are said to be conjugate points with respect to the circle S is equal to 0. And today we will be discussing the condition required for the lines to be conjugate. Children, let S is equal to 0 in standard form, x square plus y in general form, x square plus y square plus 2gx plus 2fy plus c equal to 0 be a circle with radius r and line L1x plus M1y plus M1 equal to 0 and L2x plus M2y plus M2 equal to 0 be two straight lines. We have a circle and then we have two straight lines. Then the following conditions are equivalent. What are the equivalent conditions? If these two lines are conjugate with respect to the circle, then R square into L1 L2 plus M1 L2 is equal to L1G plus M1F minus N1 into L2G plus M2F minus N2. This is a theorem, children. It is already there in the textbook. If at all this board, the clarity is lacking for you to see in the mobile, please do check in the textbook and you can follow the proof. 1 implies 2. It actually does not only implies and implies. So instead of writing formulas again, I'm taking implies and implies, which includes if these lines are conjugate, then this condition is followed, and if this condition is followed, the given lines are conjugate. Suppose that the lines are given by 2 and 3 are conjugate. If L1x plus M1y plus N1 equal to 0 and L2x plus M2y plus N2 equal to 0. These two lines are conjugate. Then what is the definition according to the conjugate lines table? The pole of one line lies on the other line. We have this line 2 as L1x. Suppose I will take this as equation 1 and this as equation 2 and then this as equation 3. Then the pole of line 2 lies on the pole of line 3. What is the pole of line 2? The pole of line 2 is minus g plus LR square by L1g plus M1f minus N1 is a formula to write the pole when a line and circle is known. Minus f plus M1r square by L1g plus M1f minus N1. Here G, F are from the equation of the circle. L1, M1, N1 are from equation of the straight line. R is the radius of the circle. And this pole of line 2 lies on line 3 because L1 and L2 are conjugate from the statement 1. And this point should be substituted in equation 3. What is equation 3? It's a line 2 L2x plus M2y plus N2 equal to 0. L2x plus M2y plus N2 equal to 0. Here x is x coordinate of the pole and y is y coordinate of the pole. Let us simplify. L2 into minus g, 2 into minus f plus N2 together. And this L1 taken inside, L2 taken inside, L1 and L2 r square by L1g plus M1f minus N1. And similarly, M2 taken inside, M1, N2. Here, L2 is multiplied with L1. Similarly, M2 is multiplied with M1 gives us M1, M2 r square by L1g plus M1f minus N1. Now here it is r square and here also it is r square. Taking r square common, L1, L2 plus M1, M2 by L1g plus M1f minus N1 equal to 0. And transform this term to other side with respect to addition, then minus will become plus. And this term should be transformed to transposing this term to other side with respect to division, then it will be multiplied with the resultant. Hence, we will be left with left hand side. R square into L1 L2 plus M1 L2 is equal to this term goes other side along with this multiply L1g plus M1f minus N1 into L2g plus M2f minus N2. It's a required condition for the lines to be conjugate. If this condition is followed, from which this can be rearranged as this form. And this statement, this sentence, this equation can be rearranged in this form, which shows that the pole of the line 1 lies on the line 2. Implies the lines 1 and 2 are conjugate to each other. So the equations, if these lines are conjugate with respect to the circle, then this condition is followed. If this condition is followed, the lines are conjugate. Is it required proof, children? Let us solve a problem using this table. We have exercise 1D 12th problem, children. Let us take a problem. Exercise 1D 12th problem. Find the value of A. If A plus 3y minus 1 equal to 0, 2x plus y plus 5 equal to 0, or conjugate lines with respect to circle. What is the equation of the circle? X square plus y square minus 2x minus 4y minus 4 equal to 0. Now we have to write the given equations. Given line, first line L1 and second line L2, and the circle x is equal to given circle equation. And let that be equation. Let those equations be equation 1, 2, and 3. You can find the value of k in two processes. One is take the line which is free from k. For example, in this case, this line. And find the pole of this line using the formula minus g plus lr square by lg plus mf minus n minus f plus mr square by lg plus mf minus n. Find the pole for this line and substitute that pole in the equation of the first line. Then you can get the k value. It's method 1. That is called general method, a precisional method. And this is the method what I am explaining is how to use the formula. Second method. Given lines L1 equal to kx plus 3y minus 1 equal to 0. L2 equal to 2x plus 5 plus 1 equal to 0. And the circle x is equal to x square plus y square minus 2x minus 4y minus 4 equal to 0. Since L1 and L2 are conjugate lines, it is given in the question. Conjugate lines with respect to the circle x is equal to 0. What is the condition if they are conjugate, children? Just now we have seen r squared into L1 L2 plus M1 M2 is equal to L1G plus M1F minus N1 into L2G plus M2F minus M2. Here, what is L1, M1, N1? What are L2, M2, M2? What is G, what is F, and what is radius R? Should be noted. L1 is from first, L1, M1, N1 are from line 1. What are that? L1 K, M1 3, and N1 minus 1. L2 from line L2, that is 2, and this is 1, and this is 5. And from circle minus G is equal to minus 2. 2G is equal to minus 2, from which G is equal to minus 1. 2F equal to minus 4, so F is equal to minus 2. And radius is root G square plus F square minus C. What is minus C value? Minus of minus plus 4. 4 plus 4, 8 plus 1, 9. Root 9 is 3. So radius is 3. Now, these values, substituting these values in the equation, let us take this as equation 1. Let us take this as equation 1, this as equation 2, and this as equation 3, and then equation 4. So from 4, we have just substitute the values. R square, R is equal to 3, therefore R square is equal to 9, is equal to, sorry, 9 multiplied with L1 into L2. L1 into L2. 2 into K. 2K. Plus M1 into M2. 3 into 3 is equal to L1 into G. K into minus 1 minus K. Plus M1 into F. 3 into minus 2 minus 6 minus L1 minus of minus plus into L2G. 2 into minus 1 minus 2 plus M2 into F. 1 into minus 2 plus minus M2 minus 5 implies 9 into 2K plus 3 is equal to minus K minus 5. This minus 5 minus 4 is minus 9. And multiplying this, taking minus common and multiplying this with minus 9 into 2K plus 3 will give us minus of K plus 5 into minus 9. Now minus into minus plus 9 into 9 gets cancelled, from which 2K plus 3 will be equal to K plus 5. Transposing K to the other side with respect to addition, 2K minus K is K. And 3 to this side, 5 minus 3 will be 2. Therefore, the value of K is equal to 2 if the given lines are conjugate. So, this is another method. And if to check whether the given lines are conjugate or not is another kind of the problem can be asked on this. Then what shall we do, children? We simplify LHS separately. We will simplify RHS separately. If we get LHS is equal to RHS, then we will say that the given lines are conjugate. So there can be two questions. First, we will give sir will give two lines, equations of the lines, and equation of the circle. He may ask us to check whether the given lines are conjugate or not. Like the points will be given and circle will be given, and he will ask us to check whether the given points are conjugate or not. Then we will prove S12 if S12 equal to 0. We will find S12 with respect to the circle S is equal to 0, and P and Q will be substituted in that equation in order x1, x2 plus y1, y2 plus g times x1 plus x2 plus f times y1 plus y2 plus c equal to 0. Then the given points are conjugate. Similarly, if we substitute here in LHS and RHS using the values given in the line and circle, if LHS is equal to RHS, the lines are conjugate. But here, already the lines are conjugate is given. Using that concept, we are finding K. So it is application type. So we will equate LHS is equal to RHS and then find K. So two types of problems can be asked. With this, we finished first bit, children. Let us move to second bit concepts, which involves finding the angle between the tangents drawn from a point to the circle, or given the angle, we need to find the locus of the point from which the tangents are drawn. Children, you all might be remember the theorem we discussed that if P is an exterior point of the circle, x is equal to 0, and if P, then two tangents can be drawn from P to the circle, x is equal to 0. How many tangents can be drawn? Two tangents. If theta is the included angle between those two tangents, then tan theta by 2 is equal to r by root h. Hope you all remember this. I'll draw again. This is x is equal to 0 and this is called P x1 comma y1. Let us draw the tangents to the circle. Because P is outside, there exist two tangents. If theta is an angle, and the tangents drawn from P touches the circle at A and B, then what can we observe? Tan theta by 2 equals to r by root epsilon. What is r here? R is the radius of the circle, and h11 can be found using the equation of s is equal to 0, the circle equation. Using that concept, let us do a problem. Second bit, first, second, third are same. And fourth, fifth is including. If I take fourth and fifth, you can also get the problems 1, 2, 3. So we will do 4 and 5 together, children. Second bit, fourth problem. Find the locus of P if the tangents drawn from P to x square plus y square equal to a square includes an angle alpha. Include an angle alpha. So here there will be two questions. It including an angle alpha. In the next question it includes 90 degrees. So first we will do the common principle and then we will talk about the different cases. What happens if it is alpha and what happens if it is 90 degrees. Given circle S is equal to x square plus y square into a square. Let P x1 by 1 be a point of the locus. Whenever we need to find the location of the locus, we have to choose a point first. Then what is the geometric condition satisfied by P children? Geometric condition satisfied by P is the tangents drawn from 2 circle S is equal to 0 includes an angle alpha. Then what is the condition? Tan alpha by 2 is equal to r by root x double 1. From which tan alpha by 2 is equal to what is radius of the circle? A. By what is h double 1? H double 1 with respect to s is equal to 0. x1 square plus y1 square minus a square. Now, it is there in terms of alpha by 2. If we want to convert that to full angles alpha, we will take use of a formula. If it is tan alpha, we will write cos 2 alpha. Because it is half angles, I will write full angles. Cos alpha is equal to 1 minus tan square alpha by 2 divided by 1 plus tan square alpha by 2. Because alpha is the angle. So from alpha by 2 to I am transferring this to alpha. So it is a formula which helps us to transform using tan formula. Cos alpha is equal to 1 minus. Substitute what is tan square alpha by 2? A square by x1 square plus y1 square minus a square divided by 1 plus a square by x1 square plus y1 square minus a square. From which cos alpha is equal to, let us take the cross multiplication. x1 square plus y1 square minus a square divided by x1, this into this, x1 square plus y1 square minus a square plus a square. As both the denominators are same, they will get cancelled in numerator. And here also minus a square plus a square is cancelled. From which cos alpha is equal to x1 square plus y1 square minus 2a square divided by x1 square plus y1 square. Is this clear, children? Now, let us cross multiply. The denominator x1 square plus y1 square multiplied with cos alpha will get x1 square plus y1 square into cos alpha is equal to x1 square plus y1 square minus 2a square. And transforming this term to other side with respect to addition and minus 2a square to the other side, we will get here x1 square plus y1 square common. So it is 1 minus cos alpha going that side will become plus cos alpha will become minus cos alpha. Minus 2a square coming other side will become plus 2a square. So x1 square plus y1 square. What is 1 minus cos alpha, children? 2 sin square alpha by 2. So 2 and 2 gets cancelled. So x1 square plus y1 square into sine square alpha by 2 equal to a square is the equation. Or you can send sine square alpha by 2 other side with respect to multiplication. Then x1 square plus y1 square is equal to a square by sine square alpha by 2. What is 1 by sine square, children? Cosecant square. So x1 square plus y1 square is a square into cosecant square alpha by 2. Dropping x dash and y dash, we will get x square plus y square is equal to a square cosecant square alpha by 2 is the required equation of locus of P. Is the required equation of locus of P. What we have done, children? We have taken a circle and we have taken a point P on the locus, and we have seen the geometric condition satisfied by P. According to the question, the tangents drawn from P to the circle S is equal to 0 include an angle alpha. Then we will get tan alpha by 2 equal to R by 2 natural. Tan alpha by 2 is equal to R. What is R? Radius of the circle. From equation it is A. And write S double bond for the radius surface x1 square plus y1 square minus x square. And we convert tan to the cos from arc angles to the full angles using formula 1 minus tan square alpha by 2 plus by 1 plus tan square alpha by 2. Substituting the tan value and simplifying, we will get the equation of required locus of P. The same question, instead of if angle alpha, if we are asking, second question I write, include angle, include, this is first part, include angle 90 degrees. That means the tangents drawn are 90 degrees. Then includes angle 90 degrees or pi by 2. Then this is circle and suppose this is point. The tangents, suppose if I have a point here, then the tangents drawn from P. This will be P. See, the tangent, this is the first tangent for example, and this is the second tangent. How much the angle? It is 90 degrees. Then, what is the condition required? He is asking. What is the condition or what is the locus of P? Just changing, instead of alpha, we will get 90 degrees. Let P x1 y1 be a point on the locus. Geometric condition satisfied by P is the tangents drawn from P to the circle S is equal to 0 include an angle pi by 2. So instead of alpha, now it is pi by 2. So 1 by 2 times pi by 2. So it is tan pi by 4 is equal to R by root x square. What is tan pi by 4? Tan 45 degrees. What is tan 45 degrees? 1. Implies 1 is equal to R by root h double 1. Cross multiplying. Root h double 1 is equal to R. Squaring on both sides. What is root h double 1? X. Squaring on both sides. H double 1 is equal to R square. Substitute the values. Substituting the values. What is h double 1, children? x1 square plus y1 square minus a square is equal to what is the radius of the circle? A square. So R square is a square. H double 1 is x1 square plus y1 square minus a square. Transposing minus a square onto the other side of this simple addition, we get x1 square plus y1 square is equal to a square plus a square, 2a square. Therefore, x square plus y square is equal to 2a square is the required equation of locus of P. Should be written. Is the required equation of locus of P. This is all about the locus question, children. The same kind, another kind is just to find the, we need to find the angle. When we need to find the angle, just you have to find tan alpha by 2, from which cos alpha should be noted. When you know cos alpha, alpha is equal to cos inverse of the value of 10. Gives us the angle between the tangents. So these are the 3 different questions that can be asked. With this, we have finished the concepts related to angle between the tangents from an external point, children. Let us do one other important question which it was asked in one of the previous papers, the intermediate papers. Second with 7th question. If the line is a polar of P with respect to the circle and LCF of ABC is equal to 1, then find A square plus B square. It is second with 7th question. Look at the textbook, children. I'll just read the question for you. A line is given and a point is given, and sir is asking us a condition. And one hint is provided to find the value of A square plus B square plus C square. What is that? The polar of P with respect to the circle is also given. But we can also find the polar of P, which is using S1 equal to 0. And then compare the given line and S1 equal to 0. We will get the value of A square plus B square plus C square. Let us do the problem. Ax plus by plus C equal to 0 is the polar of 1, 1 with respect to the circle. What is the circle? X square plus y square minus 2x plus 2y plus 1 equal to 0, and HCF of A comma B comma C is equal to 1. Then find A square plus B square plus C square. Dear children, given equation, given line Ax plus by plus C equal to 0 and circle. What is circle? X square plus y square minus 2x plus 2y plus 1 equal to 0. And let us denote the circle with S. And point is also given. Point is P1, 1 is equal to x1, y1. Since sir is asking about the polar of 1, 1 with respect to the circle, let us find the polar. Polar of P 1, 1 is equal to x1, y1 with respect to x is equal to 0 is s1 equal to 0. What is s1, children? That is s1 is equal to, write s1 for the given circle, x1 plus y1 minus of half of this, x plus x1 plus y plus y1 plus 1 equal to 0. What is x1, y1? Is a point p1, 1. So we are finding s1 at p1, 1, which will be x into 1 plus y into 1 minus of x plus 1 plus y plus 1 plus 1 equal to 0. Let us simplify children. X into 1, x1. So x1 at p1, 1 is equal to x into 1 x plus y into 1 y minus x minus 1 plus y plus 1 plus 1 equal to 0. If you have to x and x is cancelled, minus 1 and plus 1 is cancelled. So we will be remaining with x1 and p 1, 1 is equal to y plus y 2y plus 1 equal to 0. To write in the form of a line, let us write the x term with coefficient 0. 0 into x plus 2 into y plus 1 equal to 0. Then it is the equation of polar of P, which is a straight line in the form of ax plus by plus c equal to 0. If a is 0, b is 2, f is 1. This is the polar of P with respect to the circle s is equal to 0. In the question, it is given that ax plus by plus c equal to 0 is the polar of P with respect to the circle s is equal to 0. So what do we infer, children? If this is equation 3, the equation 1 and equation 3 represent the same lines. What is the line? The line which is polar of P with respect to the circle s is equal to 0. Therefore, The equations 1 and 3 represent the same line, which is equal to polar of P with respect to x is equal to 0. Therefore, the corresponding coefficients are comparable. A ratio of the corresponding coefficients are proportional. Then A, what is the x coefficient, corresponding coefficient here? 0. Similarly, there it is B and here it is 2. And there it is constant C and here it is 1. X equal to Y equal to Z. All these values are equal. Equal to what? Equal to a value. We don't know, let us take that as K. Equating each value to the K. A by 0 is equal to K. And B by 2 is equal to K. And C by 1 is equal to K. So highest common factor of A now is, or you can simplify that. A equal to 0 into K, 0. B equal to 2 into K, C equal to 1 into K, K. So highest common factor of A comma B comma C is equal to K. Implies K is equal to 1 because highest common factor of A comma B comma is equal to 1 is given. It is given in the question. We got K from here, but in the question, the highest common factor of A, B, C is equal to 1. What is the highest common factor for us? It is K. So that should be equal to 1 now. Therefore, A square plus B square plus C square equal to A square is 0 into K is 0 square. B square is 2 into K, but K is equal to 1. So 2 into 1, 2 into 2. C is equal to K, K is equal to 1. It is 1. Is the required value. A square plus B square plus C square equal to 1. I pick the question again. Because the question is asked the polar of P with respect to the circle S is equal to 0, we have found the polar of P. But this polar of P using S1 equal S1, what we have got is the polar of P with respect to circle S is equal to 0. And according to the question, AX plus BY plus C equal to 0 is also polar of P. And both these equations represent the same line. Therefore, we will compare their coefficients. And from which we will get the values of A, B, C in terms of K, which gives us the K is the highest common factor of A, B, C. But according to the question, highest common factor of A, B, C is 1. Therefore, K will be equal to 1. Substituting that the K value, we will get the value of A, B, C. When we know A, B, C, we can find A square plus B square plus C square, which we got as 5. With this, we have finished all the secondary questions, children. Let us take a problem in the third unit. If the polar of the points with respect to the first circle, polar of the points on the circle 1 is given with respect to the circle 2 touches the circle 3, then prove that A, B, C are in geometric progression. It's very easy and also important. Observe the equations of the questions given. Observe the equations of the circles given in the question, children. We have 3 equations. One is x square plus y square equal to a square, children. Second, x square plus y square equal to b square. Third is x square plus y square equal to c square. When you observe, the center of each circle is 0, 0. Radiuses differ, implies all these circles are concentric circles. We should choose a point on the first circle. For example, we can take any circle because we don't know the order of the radius of the circle, whether A greater than or B greater than C greater than. For my convenience, I am taking this as x square plus y square equal to a square. Let us take a point P on the circle. And for this point, with respect to this circle, we have to find the polar. So with respect to this circle, the point is outside. Therefore, the polar will be inside. The inside polar is touching this circle. Okay, then R equal to D for this circle. This is circle 1 and this is circle 2 and this is circle 3. This is 1, 2, 3. Then we have to prove that the A, B, C radii of these circles are in geometric progressions. First, let us take the question. Third bit, second one. If the polar of the points on x square plus y square equal to a square with respect to the circle x square plus y square equal to b square touch the circle x square plus y square is equal to c square, then prove that A, B, C are in geometric progression. Okay, children? Solution. Given circles. Let us take given circles. First circle, x is equal to x square plus y square equal to a square. Let us take this as equation 1. And as the second circle, x square plus y square is equal to b square. And s double dash next circle. X square plus y square is equal to c square at 3 circles. And let us choose a point. Where to choose? If the polars of the points on the circle. So first of all, let Px1, y1 be a point on s is equal to 0. Let us take the point from first circle. So the point lies on the circle 1 implies x1 square plus y1 square is equal to x is condition 4. Now we need to find out polar for this point P. Polar of Px1 y1 with respect to, I said, polar of this point with respect to first circle will be different, with respect to second circle will be different, with respect to third circle will be different. So the polar of the given point with the different circles will be different. So with respect to which circle is very important. With respect to the circle, x square plus y square is equal to b square. Therefore, polar of Px1 y1 with respect to x dash x square plus y square equal to b square is, write the equation, polar equation, x1 plus y1 minus b square equal to 0. Is this a line, children? Yes, this is a line. Which line? The polar of P with respect to the second circle. What is this line doing? This line is touching the circle 3. Given that, in the question it is given that line, what is this polar of P? Given that polar of P with respect to circle 2 is touching the circle 3. Is touching the circle 3. What is the condition when the line touches the circle? R equal to D. Which are the radius of the circle? Which is touching the given line. So C equal to D. D is the perpendicular distance from the center of the line, center of the circle to the line which is touching the circle. And this center is nothing but 0, 0 that we have done from the equations. And D, when we need to find out, because this point is 0, 0, it's simply mod C, that is constant in the line, minus B square by root of x coefficient square, x1 square plus y1 square. Children, from equation 4, this x1 square plus y1 1 square value is a square. C equal to modulus of minus b square by root of a square. From which modulus of minus b square is a, because this a, b, c are really, they take only positive values. So b square is equal to ac. From which we say that the square of the middle term is equal to first term into third term. Then a comma b comma c are in GP or geometric progression. This is a required condition for ABC to be in geometric progression. With this, we have finished all the important, most of the important questions of the exercise, children. And here is one special question. The tangents are drawn to the circle. One important question. Second and third one. It's next question, children. Tangents are drawn to the circle x square plus y square equal to 16 from the point P3, 5. Find the area of the triangle formed by these tangents and the third of contact of P. And this question is as same as the question explained in page number 54, example 4, children. How to find the area of the triangle. I'll just discuss the method so that you can do the problem. Both the problems can be solved. Here today's homework is complete exercise 1D. We have done many problems in 1D, only some problems left. So if you finish those problems, which are on the concept of the problems that we discussed today, show that page 54. Example 4. This is important. And that exercise problem and this problem are one and the same method. So if you listen to the theory, you can do this problem. Show that the area of the triangle. How this triangle is formed? Triangle formed by the two tangents. Formed by the two tangents through Px1, y1 to the circle s is equal to x square plus y square plus 2gx plus 2fy plus c equal to 0, and the third of contact of P with respect to x is equal to 0 is r into x double 1 power 3 by 2 by r square plus x double 1, where r is the radius of the circle. Where r is the radius of the circle. Dear children, we have a triangle and we need to find out area of this triangle. When we have triangle, we have an area. To form the triangle, we need three sides. What are those three sides? Two sides are tangents and the other side is the third of contact of the point P. Let us draw the diagram. This is about the circle and a point P in the exterior plane of the circle, and we have two tangents. Let the tangents touch the circle at A and B. Let the tangents drawn from P touch the circle at A and B. Now, this line AB is third of contact of P with respect to the circle x is equal to 0. Now we shall find the area of the triangle PAB. This area should be formed. We already know if theta is the angle, then tan theta by 2 is equal to r by root x double 1. What is r? Radius of the circle. What is this length? Root S double 1. Length of the tangent. This is also root of the length of the tangent PB. So root S double 1. Using this, we will find out area of the triangle. Solution. Given circle. Given circle. X is equal to x square plus y square plus 2gx plus 2fy plus c equal to 0. And the point P, x1 comma y1. If theta is the angle between, or we should first, we should first write what is AB. Let the tangents drawn from P touch the circle at capital A and capital B. Then we have to find area of triangle PAB. We need to find out area of the triangle PAB. For that, let us take theta as the angle between them. Let theta is the angle between the tangents. Drawn from where? Drawn from P to circle S is equal to 0. Then what is the condition we get, children? Tan theta by 2 is equal to R by root S double 1. Tan theta by 2 equal to R by root S double 1, where R is the radius of the circle and S double 1 is from the given circle. Now, how can we find area of the triangle? Area of the triangle PAB. Area of the triangle PAB, or area of the triangle PAB is equal to, we have the formula in our first year intermediate in triangles. What is that? Half. If you know the lengths of the two sides and included angle between the two sides, then we can write area of the triangle as PA into PB, half PA into PB into sine of angle between these two. So sine theta. Angle between PA and PB is theta. Half. What is PA, children? Length of the tangent, root S double 1. What is PB, children? Root of length of the tangent. And sine theta. But we know tan theta. We don't have the value of sine theta. So let us find we have a formula from which half angles are converted to full angles. So sine theta in terms of tan. 2 tan theta by 2 divided by 1 plus tan square theta by 2. So half gets cancelled. Root S double 1 is S double 1 into tan theta by 2. What is tan theta by 2? R by root S double 1 divided by 1 plus R squared by S double 1. On simplifying which, S double 1 into R by root S double 1 into 1 by S double 1 plus R squared into whole S double 1. So here root S double 1 and this is root S double 1. From which area of the triangle PAB is equal to, what is that? R into S double 1. Here it is power 1 by 2 and there it is power 1 divided by S double 1 plus R square, which will be R into S double 1 power 3 by 2 divided by S double 1 plus R square. So if you know the equation of the circle, if you know the radius, you can find the equation of the you can find the area of the triangle. And you need to know a point from which you can find out S12. With this, we have finished all the exercise important problems. And the rest of the problems which I didn't solve on the board can be solved by the concept that we discussed in webinar classes children. Please complete exercise 1D today, and tomorrow I will be discussing important concepts remained in this exercise 1D, and we shall continue with exercise 1E in tomorrow's class. And children, this webinar classes conducted by our society is to the benefit of the children, and its complete result is obtained only when you do homework and when you come up with your doubts and with your problems, and when we share it again on this platform, children. Please make use of this wonderful opportunity provided by the society and do good. Have a great day, children.